about your titration lab. Now, I absolutely love doing titrations when I was in school, so I think you're going to really enjoy this as well. Remember that a titration, the whole purpose is to find the unknown concentration of something. And in this case, our unknown concentration is of the sodium hydroxide. That's actually in the burette already. Now, I played a Carolina Biological video for you about how to set up a titration, and it walked you through exactly how to set up your burette. Here's the good news for you. It's already been set up properly. We've rinsed it out with the solution. We've rinsed it out with distilled water, not in that order. It's already been done. So that part's done. Once you get to your station, all you're going to have to worry about is actually diving in and starting your titration. So the first thing is that it asks you to measure out 5 mils, 5.0 mils of your hydrochloric acid solution. So you're going to come up to the front of the room. That's where the acid's going to be found. It's going to be in a container like this, but your teacher will have poured it into a beaker for you with a pipette. Actually, a few pipettes so groups can go together at once. And you're going to use the pipette to get out 5 mils. Okay? It's very important that you use the smallest graduated cylinder that you have, because if you're trying to measure 5 mils out of a 100 mil graduated cylinder, you're just not going to be as precise. You're not going to have as many estimated digits. We want to get it to be as accurate as possible, and the smaller the tick marks, the more accurate your answer is going to be. That's what we want. Then you're going to get back to your station and you're going to pour your acid into your Erlenmeyer flask. The next instructions tell you to get 10 mils of distilled water. Our distilled water is going to be in a wash bottle, and I would suggest that you do it directly into this. Don't rinse this out between. Go directly into the graduated cylinder with the wash bottle full of distilled water. Why? Because we know the concentration. We absolutely know the concentration of this. So when we get at 5 mils of this, we now know exactly how many moles of HCl we have. Do you remember when we do our titration calculations, the first thing you do is you calculate the number of moles of the known. That's what's important. Once you calculate the number of moles of the known, it doesn't matter your volume, it doesn't matter your concentration. What matters is the moles. And once we put 5 mils of HCl in here, we can dilute it all we want, because at that point the moles are not going to change. So adding water to this after you've measured out here is just fine. So what we're going to do is we're going to measure 10 mils of distilled water directly out of here, because that's going to get all the HCl that coated to the sides of the graduated cylinder. And you're going to add the 10 mils to here as well, just to give it more volume. Now, please, please, please do not forget to add your indicator. Half of you guys are going to be given phenolphthalein, and half of you guys are going to be given bromothymol blue. If you're given phenolphthalein first, it's going to be clear at first because this is an acid, and you're going to titrate until it turns a pale pink color. Sometimes my students forget to add phenolphthalein because it's still clear and they don't realize that they forgot it, and they keep titrating and titrating and titrating, and they're like, Miss Powers, it's not turning pink. I'm like, did you add the phenolphthalein? So don't forget to add your 3 drops of your indicator. If you have phenolphthalein, you're going to titrate till it turns a light pink, pale pink color. If you've got bromothymol, bromothymol is blue as a base, so you're going to titrate until it's a light blue. Now technically, bromothymol is green when it's neutral, so that would be perfect. If you could actually titrate it to be green, oh, you have the most perfect titration possible. Probably is not going to happen. So titrate until it goes from yellow, is what it will be at first, to a very pale blue color. You want to wait until one single drop gets it to that perfect pale color. If it's not a pale color, if it's a dark blue, you've over titrated. If it's a dark pink, you've over titrated. It should look so pale that it's almost clear for the phenolphthalein, and so pale blue it almost has a green tint to it. That would be perfect. Now, the video I showed you in class showed you going through pretty quickly at first until you start getting close. No, we've purposely picked concentrations that will only allow about 1 milliliter total for when your titration started to when it's done. So you're going to actually go drop-wise the whole time. The first thing you should do is get an initial reading of your volume on the burette, and it's very important that you are looking at estimated digits, so look at the tick marks, add 1 extra digit, And something else to take note is that it is going backwards. So 0 is at the top, 50 is at the bottom. So when you're reading, you've got to read it backwards. My suggestion, get your volume, talk to another partner, have them get the volume, compare and see if you got the same thing, and then write it down. So you want to make sure you have the proper volume. Okay, so once your solution's ready to go, you've gotten your initial volume, you're going to put this in drop by drop. So you're going to slowly open the stopcock so that it slowly comes out. As slow, whoever has the most steady hands really should be doing it. And I just added 1 drop and I closed it. And now I'm going to stir it around. You don't have to do it this slowly each time, but you'll want to go pretty slowly, because I'm going to tell you, maybe a single accidental squirt is going to cause you to be over titrated. You should go drop by drop until you are at the point of the titration's ending. Now, one thing I also want to tell you, occasionally sodium hydroxide will stick to the sides of the Erlenmeyer flask. And again, I told you that you're going to have a wash bottle at your station, and I want you to rinse the outsides of the inside lining of the Erlenmeyer flask with that distilled water. It's okay that you add water to this all you want, because that's not changing the moles of acid or the moles of base that you've been added. So add distilled water and rinse out the Erlenmeyer flask as you're going on the inside to get all the sodium hydroxide that's clinging to the inside of the flask but not in the solution in there. Maybe every few drops, 4 to 5, maybe a few drops, do that. When you feel like you're getting really close. Now when you're getting close, it's going to be pink at first. When you first put the drop in, it's going to turn pink. And as you're stirring it, as you're getting really close to your end point, it's going to stay pink for quite a while. You're going to be like, ooh, I think we might be done. And as you're stirring it, it's going to then turn clear. That means you are really close. When you think that you are really close, that means you're having to stir it for quite a while before that pink goes away. I would suggest you start adding half drops. Let me tell you how to do a half drop. At that point, you open up the stopcock so that some of the sodium hydroxide is starting to come out. And as you see, it's sticking to the end of the stop, at the end of the opening. Now I just put a whole drop in there, so you gotta be really careful. As you see the drop coming down, then you turn it off, and you'll see the drop hanging at the bottom of the opening. Take your distilled water wash bottle and squirt the distilled water directly on that drop to get it in there, get it to fall in, and then rinse it in again with that wash bottle again to get it in here. Now, here's what I want to tell you about over titrating. If this is not a perfect pale pink color or clear, like pale clear pink, like as light pink as possible, you've technically over titrated. If you get like a dark pink color, you've over titrated. You've added too much base, because now the solution's basic. You're trying to stop it when it's neutral. So if that happens to you, here's what I want to tell you. In your table, write down your volume, write it down as is, and under observation say over titrated, dark pink color. So in your observations, you're describing exactly what happened in your titration. Here's what I want to tell you. You can use that data point, you can use that trial if you only over titrated by a single drop. 1 drop, it was clear. The next single drop, it turned dark pink. I will take it. That's fine. But if you accidentally, like you're titrating and you're like, ooh, we're really close, and your partner or you accidentally budge and you actually accidentally let in a few drops or maybe even a squirt, if that happens, that trial should not count. So it asks, the lab requires you to do 3 trials. I need you to do 3 good trials. Let me tell you what I mean by a good trial. It's a trial where maybe you over titrated, but you did not over titrate by more than just 1 drop. 1 drop over titration is fine, but more than that, you gotta redo it. So today in your lab, make sure that you do 3 good trials. If you have time for a 4th, awesome, but definitely 3 good. If you over titrate by more than a drop, you're gonna have to replace that data, that set of data points for a new trial. Okay, so good luck. I hope you really enjoy your titration.